Hello and welcome to another episode of Invalid Entry, and today we are going to be doing the long-awaited heartbeat sensor. As you can see right above my head right here, this is my heartbeat, this is my heart rate. It's a little animation, it's not actually an ECG. I'm going to try leaving that running there. It is going to break in a second because I'm going to show you how it actually works. I'm today going to show you how I program this in completeness. It may be one or two episodes because there's two distinct parts to this program. There is the detection of my heart rate using some off-the-shelf equipment, and there is the animation. And I thought I'd start with the animation because that's pretty cool and pretty funky, and I'll show how it all fits together. There's basically uses two off-the-shelf components. It's using an ANT+ dongle, and I will show you that in a second. And it uses a dongle to actually do the communication. I actually made a little animation here which I'm going to talk through. So for this project to work, you basically need to have a volunteer, a fun YouTube streamer. Now this isn't actually, my friend Stitch asked me to make this for him. I was like, yeah, it sounds like a good project. And I did it about 2 or 3 months ago, and this is actually my fourth, or this will be my fifth version of this project, but the fourth one is really quite solid in terms of how it works. So you need a person, they basically strap a monitor around their chest, which I'll show you one in a second, and that's going to send packets using a protocol called ANT+, which is a bit like Bluetooth, but it's not Bluetooth. It uses the same frequency, so you can get some radio interference there. Also uses the same frequency as Zigbee, which again isn't Bluetooth, but it's that local area network type thing. Then what you need is your computer, and on your computer you need to add a new dongle, an ANT+ dongle, because it's not Bluetooth. Even if you have Bluetooth on your computer, you won't be able to receive the data packet. So you basically drop that onto your computer. Then what we do is we write basically a script which is going to receive the data and interpret the data. And I am going to use Python because I find it nice and fun to program with. I don't need to get too bogged down with code too much. I can just concentrate on the business logic and display logic. And of course I'm going to use Pygame. Now my original plan was to use an animation, or to have an animated step. So basically to say, here is a heartbeat. Now people do ECGs, get very annoyed by people who it just goes up and down. It's supposed to have a little bump in front and a little bump after. Otherwise it's not a natural heartbeat. So a little bump, then a big bump, then it goes down. And we may get into an interesting fact about my heart going on. So we're going to take an animation of a heartbeat, or at least a construct of what a beat looks like. We're going to take data from the heartbeat monitor. We're going to feed those together into a Pygame to actually produce an animation which looks just like the one above me. As you can see, this is a lot easier if you know it actually works at the end. Now, the idea from this, going back several videos showing how this actually works, is I generate that at the same time I'm doing something else like playing computer games. So here we are, this is Minecraft. Obviously it's Minecraft, I'm fighting a very, very ugly iron golem here. So you run this on the same computer as your gaming computer and your OBS stream. So what I do is you take the game feed, you tell OBS to take the game feed, you tell it to also take the video camera feed and any other overlays you want, and use Chroma Key on the output to actually say, now drop that in. Now I've actually here just put mine behind a black window because it sort of disappears. When you're playing games are often quite dark, so you need to work out what colours work for you. So I'm going to put that back down there, just to give a nice black background. So yeah, here we go. We're going to tell OBS now to overlay my video picture. We're going to overlay the heartbeat. See, magically coming in there. And then we're also going to overlay any other information we want using OBS. OBS, of course, good streaming platform. You then send the output from OBS straight to your streaming partner, Twitch, YouTube, whoever. I actually record mine to disk and then edit it and then upload it as a video rather than a live streamer. But this allows you to do this interaction, do all the cool animations and everything else. And we do this, of course, for fun. We're doing this for fun, not for profit or to validate our existence, because that would be bad. That's basically it. I'll show you the equipment actually as it is, and to do that I'm going to go straight to my video feed like this, and this is where I get demonetized because I actually am wearing it. So what you have, and I will zoom out on my camera once I've taken it off, it's 9 o'clock in the morning, it's a bit cold in my shed, So what you have is basically a dongle. These are quite cheap dongles. You can buy expensive ones. I chose not to spend lots of money on it just for this project. This was about £20 on Amazon. And you also need a tiny little dongle. The dongles are really small. This will break my overlay side. That's the dongle. It's a little USB. It looks like a Bluetooth dongle, but it isn't. It's an ANT Plus dongle. Again, I didn't get an official Garmin one. Garmin are the people who own the protocol, but it's an open-ish standard. It's not an open standard, but it's a consortium standard, so other people can license it and use the standard. Whether these are licensed because they've come from China, you never quite know. But they're advertised on Amazon as ANT Plus compatible. This is a Kuspu. That shows up in the camera. A Kuspu dongle. And the way it works is basically, this takes a coin battery in a little device, and then it has these pads on the inside. Again, you can just sort of see the reflectiveness here, and they're conductive. So it just button pops onto those, and then you put this around your chest. Now, fun fact number one: you put it around your chest, just under your pecs. You put it on under your shirt so it touches your body. Okay, if you put it on over your shirt, it's not going to work. And actually, it forms a circuit and it picks up the very small voltages in your body. It is not an ECG. So when you see an ECG, you're actually picking up the tiny variations in the voltage, and you actually the path, the trace actually is the voltage currents of your heart. This is not that. That is only picking up the major pulses and therefore what your rate is. So the rest of the animation is completely fake. And you can tell that, especially on mine, because I have a slightly dodgy heartbeat. Fun fact. So I'm just going to put this back on. It just sort of clips on around your heart, sort of shuffle it up so it's in position. I just have to restart my script because I unplugged the USB device halfway through it. And then we shall go back to the main. Oh, look at that animation. Weird how the animation worked one way but not the other, I don't think. So there we are, running again, heart rate detected. So what I was going to try and focus on today especially was how to build the basic script. So I actually want to open a new code window. I'm going to stop the recording a moment, get my Pi window set up, and we're going to build the animation, show how the animation it works to get that cool fade effect and various bits which make up that animation. Alright, so what we're going to do first of all is we're going to set up the very basics of a Pygame animation. I'm going to bring in the stuff that you basically need to do to get it to work. And I'm going to use my crib for this. I've just lost my crib because I moved the other thing to the foreground. Here we go. I'm just going to zoom back in so you don't see all my rubbish in my background. Don't get distracted by all this the crap on this side. This side's nice, it's set up for streaming. This side, piles of material. So what we're going to do here very quickly is we're going to do our import. So if you're going to import Pygame, Pygame 2 is out. It's past the 20th or 19th of October. It's 20 years old, Pygame, which means it's a good, strong library, good, strong community. Documentation could improve, but it's a good, strong library. Basically, some people do from Pygame, import Pygame as PG. I like having Pygame as Pygame. I don't mind typing the extra buttons. The reason why I put some lines at the top there was I was going to come back and add more lines above the imports, which is a little bit unusual, but you'll see why later on. Especially when we do the ANT Plus stuff, it's going to come in. So basically, Pygame should be inited, and if you don't do that, you can have weird side effects. It sort of works if you don't do it. But if you start moving windows between screens and things, and also if you use fonts and various other things, it goes very weird. So you always init your Pygame. And the next thing we're going to do is we're actually going to set the screen. So I'm just going to make a variable size. I'm going to make it 500 by 200. And the reason for that is that I want to know where the middle is. So I want a nice even number up and down. Don't really care how wide it is, but I do care that the up and down is an even number. If it's an odd number, it will still work. You might just get weird anti-aliasing going on. We'll set the Pygame screen equals pygame.display.set mode. Now, size flags equals pygame.noframe, and we want no frame because when we import it, it's going to into OBS, we don't want to have the window around it. So we just say, don't give us a frame, won't have the frame, no need to get rid of it, no need to crop it in OBS, which takes up more resources. Pygame.display.set caption part 2. Now the reason I'm putting that in as a different one to my other one is because OBS is going to find the window based upon the screen name. By the way, if you notice it fade out at any point, that's just because of a bit of detection I put in, because sometimes it loses synchronicity with the device. But it gets it back, but I made it fade out when it's lost that synchronicity. Even though there is no Chrome, I think that still sets the caption, the invisible window, so the thing can find it. That's all you have to do there. We're also going to use a clock. I actually only found out about clock. I put a weird space in there recently, and this basically means we can run at a nice 30 frames a second or 15 frames a second. We are going to be frame locked on this one. It's a very interesting thing to be frame locked, because it basically means it's when you do computer games, whether you're frame locked or not, basically means as you get faster computers, your game goes faster or make it unplayable. We're also going to make an alive equals true, so we can control this thread a bit. While alive for event in pygame.event.get, if event.type equals pygame.quit, which we shouldn't do because that's basically closing the button doesn't exist anymore, live equals false, and also elif event.type equals pygame.key down. Now this is really important because I've taken the Chrome away, there's no way to quit. Print pygame.display.quit alive equals false. Because the quit here does that implicitly, we're basically giving an alternate way to quit at this point. That's all you need to do for the framework, and what we're going to do now is actually make sure it doesn't go too fast. Clock.tick. I want it to be 30 frames a second. I'm going to hard code my values in here. The copy I'm going to put on GitHub will actually have all the variables, all these magic numbers we put into variables at the top, which can then be overridden either by editing the script or by editing environmental variables, and I'll show you how to do that in another video. There will be a smaller video on how to just run the thing if you just want to run it, which I also really said at the start. I might come back and add that in. But basically that is the most basic thing that's going to go on. Now, if I run that, and I've got a window here. So I've got Pygame already installed, pip install Pygame, and now what I'm going to do is do Python 5. This is my 5th generation, as I mentioned, and I didn't put a colon there. There we go. It's going to be a pretty boring window. Doesn't do anything because I haven't done any animation whatsoever. So what we're going to do now is we're basically going to roll, make a line go across the display, and I'm going to worry about making it go up and down separately, but we're going to make a line go across the display. And the way we're going to do that, it's going to be a little bit weird, and you've got to trust me. I know I'm going to want to fade it out, and to fade it out, I can't actually. Originally, I thought, oh, what I can do is I can basically fill the display with a colour. Usually, fill it completely black, and then you lay on. You can fill the display with a colour, but the colour will be solid black, but with an alpha of like 1. Then every iteration is basically making it a little bit darker. But obviously, I'm drawing a new segment of the line every time, which will be bright green. So every line, every time I fill the display with a bit, so it means the oldest thing's going to be darker and the newest ones are all gradiented more and more bright, and then the newest thing is full brightness. That's the basic premise. You can't do that on the base display because the base screen doesn't have an alpha value. It is just numbers. So one of the tricks we have to do straight away is we actually have to make another screen. We actually have another surface, and we actually need to have 2 of the surface. Okay. So the first surface we're going to have, I'm going to call drawing, because this is the surface I'm going to. It's just called size. I was going to do screen.getSize, but I don't need to. Flags flags. My fingers are not good this week. Pygame.source alpha. So that makes it an alpha. All my colours here will have 4 digits to it. And just to confirm, I'm going to make it black, but I need to make my black a full alpha black. Okay, and we're also going to make another surface. Pygame.source alpha. Now you might think here I'm going to make this black, but not quite as dark. And I know what I just said, but I'm actually going to make it white, but nearly white. Okay. The lower the value here, the longer the trace will last on the screen. So I'm going to set it to 250 at the moment. Play around these numbers. Again, as I say, this is really my fade factor, and there's a reason for that. Is because the way that I'm actually going to overlay that onto, I'm actually going to use it as a multiplier. So I'm actually going to blend the two together and say multiply the values there up by this factor. So these values here, they're going to be 0, or they're going to be green, or whatever colour you want to use, and then it gets multiplied out by that factor there. So what we're going to do is actually now use it. We're going to be requiring a couple of look. I don't know what's going on with my typing today. Location tracking values. Okay, what we're going to do is we're going to actually try and remember where we are across the screen. Okay, so I'm going to have this thing called pointer. I'm going to make it just off the left of the screen, and this is going to be how far across the screen I am at a time. And I'm going to make my speed equal to 5. Okay, it's 500 pixels, so it's going to take 100 frames to get across the screen. And again, just making that number up. So basically, in this loop now, I'm basically going to say next pointer is equal to pointer plus speed. If next pointer is greater than screen size 0, which is my width value, then pointer is equal to minus is equal to 0, else pointer is equal to next pointer. Right, and that's the end of my run. Okay, so my that clock.tick shouldn't have been in there, should have been there. There we go. Whew, that was always close. So basically this is going to be my draw a line at height from pointer to pointer. Okay, and we're actually going to need last height is equal to the size 1 divided by 2. Now I'm going to use this double slash divide to always give me a round number, so I don't have to do math.floor or any of that stuff. It'll give me always give me an integer. So basically at this point we're going to draw. First of all, we're going to blit. We're going to draw a line and we're going to blit it onto the surface, because we're going to go draw the line to drawing. We then have to blit the drawing onto the background. Okay, trust me, in a second it will make sense, I hope. So the first thing we do is actually draw the, well, it's the second thing we should do is draw the line, but pygame.draw.line, and I'm going to draw it on the drawing, and it's going to be colours. I'm going to go for a random colour. I'm hoping this RGB 200, 230, 255, because the alpha layer, RGB, and then it's the coordinates here are my start coordinates, which will be the pointer, last height, and then next height equals last height. Then I'm going to just set that there, that's fine. And it's going to go to the coordinates, I don't know why I use an array there, I'm going to turn that into a tuple. just because it's a bit nicer for me. My next pointer, next height. Okay, so these are going to be 100 at the moment because 200 divided. It's going to be nice. It'll be nice and easy. So that's going to basically draw that on. Now that isn't going to display on this screen because what I should always do is I should do 2 more things to actually make it work. We need to screen.blit the drawing. Because it's the same size, it's going to be at 0, 0, top left, fills the entire screen, and we also need to do Pygame.flip this, which causes it to actually appear on the surface. If you don't do that, it won't actually update the underlying thing. So here we go, and you see it goes across. It goes across quite nicely. It's a purple, which is what I wanted, so you knew it was different. I'm going to quit that. The other thing I'm going to do here is, I think the next argument on here, if I pass another argument in, will be a line width. So I'm just going to make that like a 7 at the moment. So it's not more obvious to you guys watching, because you want nice chunky lines. Now if you notice here, there's no fade out going on, so we don't actually know if it's looped correctly. I suspect it has looped correctly, and that's the start of my heartbeat monitor. Put a space in there and it will get rid of it. Now to actually get rid of that, to actually cause it to fade out, here's the fun trick. Okay, what we're going to do is go to drawing.blit, and we're going to take the alpha surface, which we haven't changed anyway, it's still that colour. Okay, we're going to blit it to 0, 0, but we're going to tell it to blend it. We're going to multiply each value, and it will do that really fast. Okay, so at this point what we do is we do the I put too many brackets in, I bet. Yeah, Pygame.pygame. It's not me paying attention. And as you can see here, it is fading out because you get that line going in. So what we can basically do here is start playing around with just exactly how fast we want it to play out. Now that's at level 250. The maximum number I can put in here is 255. So basically we're playing with just 4 or 5 numbers. It's 253. Let's put 253 in. And that fades, but at 255 it will basically have I got that backwards? At 255 it will always be present. I said that wrong actually. So we can lower it down. We can go to like 245. There you go. There, it's fading out a bit faster now. There you go. So that's the fade out basically done. Now what we're going to do is start playing with actually making it into a heartbeat. We're actually going to make it go up and down, okay? So there are now multiple ways of doing this. There's several tricks we can do. The way I approached it was basically to say that you want to decide when to have a pulse, okay? So you can either use the Pygame events method, or I've seen other people online, by the way, build like robot costumes and actually have an external event make a pulse. So you could do I've done tying a web server in before. You could then use that to then say trigger a pulse using a Pygame event. So basically, I'm going to have a couple of pulse tracking data. Now, what I'm going to do is actually have a map of values that I want it to go up and down. So I know where my middle line is, but I'm going to say I want it to go up and down by a set of values, okay? And this is where it's going to be. So pulse parts is going to be an array, and this is going to define that up and downness, okay? So I know I need that little bump in the heart rates go up a little bit, then they go up quite a lot, and then I want them to go back to the middle, and I want to go down, and it should go down by not as much as it went up. And then I believe there's a little wobble afterwards, isn't there? Now, this is actually the numbers I use for the heart rate directly above my head. So you can sort of see as it goes across, or you should be able to see it goes up a little bit, then it goes up a lot, down, and then there's a slight pause, and it goes down, up again. And that's that second sub-pulse, okay? So that's mimicking that. But you can play around with these values to get a heartbeat which looks like yours. Now, interestingly, your heart has two parts to it. It has the top and the bottom heart, and it goes budum, budum, budum. And that's what that is that budum. Now, what's fun is my heart actually goes budum, budum, but, budum, budum, but. So that's how you know this isn't a proper ECG on my heart. Because it doesn't do it all the time. I'm not about to keel over and die. But yeah, it's an interesting. There's a difference between this, where I pre-program that heartbeat in, versus actually what it actually is. So if you get a real ECG, what we'd actually do is take the values of the ECG as they came out, the actual voltage levels out, and feed them in here. The problem is a proper ECG machine probably cost you in the hundreds of pounds or dollars, if not thousands. So as a medical device, this isn't a medical device, it's a heart rate detector, not an actual ECG. We're making it look like an ECG with some cool gimmickry. If someone wants to acquire me an ECG, I would more than happily program this up for you. But until I have an ECG with an API. Bit of fun. It's fun, remember? Don't use this as a method. And the other thing is, because it's not an ECG, the numbers may be inaccurate, because also the quality of the gear and Garmin. You can use Garmin watches because they're also an ANT plus protocol. As you can see, my heart rate varies massively because I only get a pulse every minute, every few seconds. So it's called guessing what the pulse is. It's not actually measuring it for a minute and saying, these are how many beats you've had in the past minute. The other thing, just so people are aware, I want to say this now, is if you're doing this in a computer game, your heart doesn't instantly speed up. Your heart actually speeds up over time. And what we've managed to tell is that we use this with Stitch, who plays Modern Warfare. Like, he can be absolutely wasting people away and his heart rate doesn't really go up. But when he gets tense, when he gets stressed, first of all, he stops talking and then his heart rate goes up. And it's really quite interesting. When he's listening really hard, he can hear footsteps, he's trying to work out where people are, he knows someone's coming from, that's when his heart rate starts going up. So it's quite interesting at seeing when the heart rate goes up, and it goes up over minutes, not instantly. It's not these jump scares. But once it has gone up, it's how fast it comes back down again. That's your measure of fitness. Enough about hearts, back onto programming. So, otherwise we're not going to be done today. Basically, what we're now going to do is use these to actually do. So, pulse. I could use two flags. I could use like pulse in progress or pulse. I'm going to put that to -1. Okay. And the reason for that is I'm going to use it to know where I am in this array. But if I'm at -1, it means I'm not going through the array. Okay. So at this point, this is where we're going to mess around with this last height. Okay. If pulse is greater than 0, if pulse position is greater than pulse parts, len pulse parts. So this, if we change that array, I don't need to worry about the XML. I wouldn't hard code that there. Pulse position equals -1, and next height equals. Now I'm going to put a scaling factor here because I don't want to move by 6 pixels. I want to move by up to 100. So if I want to think that my maximum height of the screen was, I made 200 tall, I'm in the hundreds, so my maximum peak here should be between that. So I can make that like 11 and it will go up 66 pixels. I can make it like 15 and it will go up, 50 plus 25, 75 pixels. So you want a scale factor that's appropriate. If you make that too high or make them look weird, I actually think I want a scale factor of 10, which probably means I didn't actually need to make a display of 100. I could have got away with the display was a bit narrower. If you make it too high, it won't look right, and looking right is important. Also, your line width matters, because if it's too steep, the lines begin to overlap slightly just because of the speed going across. So playing around with this speed figure here, which is really how fast you progress across the display, and this scale factor, this vert scale factor, if I can call it vert scale factor there. So the next position pointer here, if we're if we go back to -1, the next height will equal the size, and I want the vertical height, which is the second factor, i.e. 1 divided by 2. Okay. At this point, we're basically going to say the next height. Actually, that's in that else. At this point, so if we're not in a pulse, it's just always going to be halfway through the size. At this point, what we're going to basically say is that if it's not, we're actually going to take the next height is equal to the size, is equal to the pulse parts pulse position. So this will give us one of those numbers times by the vert scale factor. Now that's going to give me a number, a positive or negative number, but actually I want to be size 1 divided by 2 minus that. And I'm going to put some brackets in here. It should do the division here before it does the subtraction. I like to put the brackets in because then it's obvious it's going to do the first half and then it's going to minus the second half. I'd like to put the brackets in for my readability, not necessarily for the optimization. So basically that's going to pick that vertical position as it goes across. And it always going to pick that. And also what we're going to do is we're going to do pulse position plus equals 1. So it's going to move afterwards. So I'm actually post-incremented on the way around. So what we're going to do now, I could have done this the other way around. I could have made the next height, incremented at 1, then checked if it was over the end and reset it, but I did it this way. So what we're now going to do is we're going, and that next height I've already used, so that should work. Now that doesn't actually trigger the pulse. So what we're actually going to do here is last time triggered equals, we need to have another import from date time import date time time delta, because we're going to use some time deltas. If last time triggered equals date time dot now, and we're also going to have dot now. Thank you. We're also going to have another factor in here, which is pulse time time delta seconds equals 1. It really annoys me. I use seconds equals 1 a lot. It really annoys me that that's a plural when you use 1. I'm not saying that I would override time delta, so I'd say second equals 1. I'm just saying it annoys me. Wouldn't fix it, just annoys me. A lot of things annoy me, really, and it's very hard to get through a day. So what we're going to do here is we're basically going to say if last time triggered minus date, or rather, because time works the other way around, date time dot now minus last time that triggered is greater than time between pulses, i.e. it's been more than a second. Now I've used datetime.now several times here, so what I'm going to do is just do now equals datetime.now. So I'm not calling that function twice, because it will actually do that twice there. I just say it's now there. No milliseconds will have passed between those two calls, so we don't need to call it a second time. If that's the case, what we can now do is basically say pulse position equals 0. Now I'm going to make it equal then, because I do set it to -1 otherwise. Pulse position equals 0, which means it will go into the next flow, and therefore it will calculate that height. So we should get a pulse every second. We won't get one in the first second, we should get a pulse every second. So here we go. And we went out of range because here that should be greater or equal to, otherwise it will run off the end of the range. So that's 1 pulse every second. Notice that you're beginning to get this overlay going on. You begin to get they're not really fading out fast enough for my liking. Notice you're going to start getting almost like a spirograph effect because it's not exact multiple of steps long. They're going to start piling up. They do fade out, but not quite fast enough for my liking. So I'm just going to go back up here and change that value there back up to 2. I wonder what the value actually needs to be. I wonder if lower. I actually thought lower was worse. That does look worse. So I'm going to put that back up to 252. That seems to be going faster, fading out faster. The purple seems to last around longer than the other ones. The other thing is when you do the OBS overlay, what you'll notice is that the overlay actually makes it fade out even faster than what you do because of the way that the alpha chroma key works. It basically says this is too close to black and makes it disappear. So don't worry if you've got a very slight gradient going on there. I am actually quite surprised by how. I wonder also if it's an impact on my line colour being a composite line colour that it's actually getting a factor there. So I'm actually going to make this just blue for the moment and see how that works. No, it's not really having much of an impact. It's still coming along. So that alpha surface fill. So that's at a 255 there. We're just going to debug this a second. I'm just going to look at my reference. Alright, yeah, no, I just checked my reference. In my reference, I have it set to 253, and the chroma key, when you chroma key that in fact, I can do that right now. What we're going to do in Streamlabs, and I'll show you my Streamlabs very quickly, is I'm going to set up a second heartbeat monitor. So basically, window capture, add source. Which window do I want to capture? I want to add a new source, whatever. I'm going to delete this in a second, and I'm going to capture my Heart 2 window. Let's go look at that. Pretty horrendous, and it's going to come in there. And what I'm actually going to do as well on this one is you right click and go down to transform. You want filters, and in filters you want to add a filter. You want to say in here you want to say chroma key, and then the key color I say custom because I'm doing custom one, and I want it to be the black as pitch. As you can see there, it's immediately made it much darker and harder to see. So you want to pick your colours quite distinctly, and it's actually made that really hard to see. So you want to think about that line width, just because of how close that is to black and how the chroma key works. The lime green obviously works quite well. I'm actually going to delete that now. And that is basically working as an overlay though. So you probably want to, you see there, it's gone a bit over the top of everything. So the colours I actually use, I'm using 253 there on my actual one, and the colour I'm actually using is not that, but that, and then that gives you that nice lime green, almost like it's an LCD display, and it does fade out quite slowly. I am quite surprised at actually how slowly it fades out. If I'm completely honest with you, I am a little bit surprised by that. But basically play around with the values until you get a value which works for you. It does matter. Getting your own artistic style does matter. Now the only issue now is obviously that this time between pulses is completely wrong. So the next part of this is actually to work out what that time between pulses actually should be. The other thing you can do as an extension is you can bring a font in, and you can do a text overlay. So in my one, I've actually put the heart rate as a figure just there, so you can actually see what the value actually is, rather than say, is it going up, is it not? When you have really subtle changes like 80 to 81 there, you're not going to see a drastic thing. Now, just to prove this is working, because I haven't actually proved it is working now, just do random numbers. If I really like I can actually make my heart rate go upwards. Apparently I can't. Apparently the entire thing is completely fake. Either that or I'm really fit and can't do it, so you have to strain all your muscles, really tense all your muscles at once. Which makes my voice go funny. I can make it go to 90. Usually I can make that jump to about 100, but I'm obviously being very... There we go, there's 100. And if you then relax and calm and think about nice wind blowing in the rushes of green pastures of Norfolk, sailing gently on a summer's day. Sailing's quite stressful for me, if honest with you, because it's a bit manic. But yeah, that will go back down again. I haven't died. Anyway, I'm going to stop it there because that's the animation done. As you see, as an animation, it works. Next time, I'm going to show you how to integrate the Ant Plus dongle or the Ant Plus code in. There's a few bits of technicality when integrating the Ant Plus code in. Mainly because of how the networking works. There's a bit of threading to go on. There's a bit of library issue with libraries aren't launched on PyPy. But yeah, as a concept, this works really nicely. And yeah, so see me in the next episode. If you like this, if you have any comments, if you want to talk more about how the Pygame layout or how the OBS works, leave me a comment, let me know, and yeah, we'll crack on into the next video.